We're going to be taking a look at the triangle inequality, or the Minkowski's inequality. And similar to what we did in the last video where we looked at the other inequality, it's going to be a very brief look at this. We're not going into too much detail. We're just showing what most linear algebra courses will require you to know. So this is a very barely scratching the surface video of this. If you need more details, there's plenty of other resources available that will give you that. So we call this the triangle inequality, and it's essentially going to say that the norm of x plus y is going to be less than or equal to the norm of x plus the norm of y. So let's go ahead and get some vectors over here to have a little bit of an idea what's going on. So we have one vector here. I'm going to put this as x, and I'll go ahead and I'll put another vector y over here. So then essentially this over here, this here would be the vector x plus y. That's what you get when you add the two vectors together. They are, head to tail. So that's simply what you're going to do to add them together. Now this means, we'll go ahead and put some of this in words over here. This over here is going to mean this length has to be smaller than this. So we're essentially, what's the easiest way to visualize this straight up, right? So the length of x plus y will be less than or equal to the individual lengths summed, simply because the shortest distance between between 2 points is going to be a straight line. I just took the time to write that out because I just think it's easy to have a way to visualize this. If you can visualize why this is, then you're going to have no problem understanding the rest of the things. We'll see it. The addition between x and y, when you add x and y and then you take the norm, that's going to be the quickest way to get between, let's say, point A and point B, right? This other way, whatever way you pick between x and y, the only way that x and y are going to give you the fastest route on their own, besides when you add them together, is if x and y were both in the same direction. So say this would be x and this would be y. Then you're going to have x plus y, the norm of those vectors individually, will be the same as the norm of the vectors together. So in any other case, if they're not going to be both pointing in the same direction, then you're just not going to get the best answer, which is why when you add them together, it's always going to be less than or equal to, in that one case, than when you were to just have them separately. So that's essentially why this is the case. And we'll take a look at a bit more information on this. Let's go ahead and look at this for a bit more. I have a bit more room here, so I can talk a little bit more about this. But that was a general overview. So let's say let's go ahead and grab that law of cosines. Now, for the law of cosines, we are going to, I'll show you what we're going to do. We're going to show the positive version of the law of cosines. So x plus y squared. So we're looking at the positive version. So here, plus instead of minus, and you're going to ask what effect is this going to have on the other side. I will show you. We will have the norm of x squared plus the norm of y squared plus, instead of a minus, we have the plus here, so plus version, plus 2 norm of x, norm of y, cosine of the angles between them. So this is the positive version of the law of cosines. When we looked at the law of cosines, we saw it with minuses. So there's 2 places where you have the arrows. We had minuses instead. Now, essentially, how this is going to be different, I can go ahead and draw you a little diagram over here, just something brief. Say we had x over here. Then we had, minus y over here. You'd have something like this, and you'd have your one angle here. And over here, you'd obviously have pi subtracted by that angle. So we're essentially replacing y with negative y for the law of cosines. And we're going to see that's how we get the pluses there instead of the minus. So with all this being said here, right? With all this being said, we know that this term over here, we know that cosine of this angle, which we saw with the other inequality, is always going to be less than or equal to it's always going to be less than or equal to 1. So just for the sake of this video, we can essentially drop that. Oh, I'm running out of room over here. I'm running out of room. What do I want to do? Okay, I'm going to sell back some of this space over here. So we've already seen this, so we don't need to look at it. I'm going to sell back some of this space because I'm running out of room here. And with that being said, then we can essentially go ahead and say this. X squared plus y squared, so the norms of these, plus 2x y, because the cosine is going to be at most 1. So we can go ahead and we can remove that. And this here, we're looking here at an exact square. I got to save that space, right? So we're looking here at an exact square. Which would mean that we could go ahead and we can pack this up. Norm of x, norm of y squared. So we're packing that up because it's an exact square. And you can see how multiplying this out would give you what we had before. And this is going to imply that, this will imply x plus, whoops, the norm of x plus y is going to be less than x plus y, which is the inequality we really want, right? And this is essentially for the same thing that we saw before. We know that if the two vectors are pointing in the same direction, this is going to be the only case where you're going to have both sides of this equal to each other, right? Because in this case, x plus y, and then the one between them together is going to be the same. Any other situation, you're going to see that x plus y is going to be shorter than adding the norms individually, just simply because any other path that's not a straight line between the 2 points is not going to be the quickest possible path, which x plus y norm is always going to give you. So anyways, this was looking at the triangle inequality. If you have any questions, leave it below. Once again, a very simple look at it. I'm just giving you what you likely need to know for a linear algebra course. There might be some more advanced courses where you need to look at this a bit more in detail, but for the most part, I don't think you guys are going to need it. At least I don't think most of the people watching this video will need it. So I hope you guys enjoyed. If you like this video, subscribe, and I will see you guys in another video.